You've seen a cube. You know what it looks like. 6 faces, 8 corners, 12 edges. Simple. Now imagine the 4D version of a cube, a shape so strange that you can describe it with math, project it into lower dimensions, even animate its shadow, but you can never directly picture it the way you picture a normal object. That shape is called a tesseract, and today we're going to get as close as humanly possible to understanding what 4D actually looks like. First, let's build the idea from scratch. A point has 0 dimensions, no length, no width, no depth. It's just a location. Move that point in one direction, and you get a line, 1 dimension. Move that line sideways, and you get a square, 2 dimensions. Move that square upward, and you get a cube, 3 dimensions. So what happens if you move that cube in a brand new direction, one that is perpendicular to length, width, and height all at once? You get a 4D version of a cube, a tesseract. That's the simple definition. The problem is that a fourth spatial direction is not something we can point at. It's not up, down, left, right, forward, or backward. Our senses were built for 3 dimensions, so we don't have direct visual intuition for a fourth one. But we do have a trick. We can study projections and cross-sections. Think about a cube casting a shadow on a wall. A real 3D object becomes a flat 2D shape. The shadow isn't the cube itself, but it still tells you something about the cube. Now push that same idea one step higher. A 4D object can cast a 3D projection into our world. That means the famous cube inside a cube connected by lines image you've seen online is not a tesseract itself. It's a lower dimensional projection of one, like a shadow. It's useful, but it's incomplete. You're not seeing the true 4D object. You're seeing a 3D translation of something larger. And then your screen turns that 3D projection into a 2D image. So by the time a tesseract reaches your eyes, it has already been reduced twice. That's why it looks weird. But projections are only half the story. The other half is slices. Imagine a world that is perfectly flat, like a sheet of paper. The creatures in that world can move left, right, forward, and backward, but up does not exist for them. They live in 2 dimensions. Now imagine lowering a 3D sphere through their flat world. What do they see? Not a sphere. They only see the part of the sphere that intersects their 2D plane. First, a tiny point appears. Then that point becomes a small circle. The circle grows larger, reaches a maximum size, then shrinks again until it disappears. To a 2D creature, a sphere passing through its world looks like a circle that appears, grows, shrinks, and vanishes. That is exactly how higher dimensions work. A lower dimensional world never sees the full higher dimensional object. It only sees the slice that passes through its space. Now scale that up. We live in 3D space, so if a 4D object passed through our world, we would not see the whole thing. We would only see its 3D slices. And those slices could change in ways that look impossible. A tiny sphere might appear from nowhere. Then it could grow, distort, split into separate pieces, merge again, and disappear, not because the 4D object is changing shape in its own space, but because we are watching different 3D cross-sections of a larger object moving through a direction we cannot perceive. So if you ask, what would a 4D object actually look like? The most honest answer is, it would look like a sequence of changing 3D shapes. Not one object, but more like a 3D movie of slices. This is why 4D feels so slippery. Your brain wants one stable mental picture, but the best it can really do is track changing cross-sections and distorted projections. Now let's make it even stranger. Imagine those flat 2D creatures again. If you pushed your 3D hand through their world, they would not see a hand. They would see strange 2D shapes appearing out of nowhere. Circles, ovals, changing curves, even multiple blobs if several fingers pass through at once. To them, it would look supernatural. From your perspective, it's trivial. You're just moving a hand through their plane. Now flip that idea. A 4D being interacting with our 3D world could look just as impossible to us. Objects could appear and disappear without crossing normal 3D space. A sealed box might not be sealed to it, because it could access the inside from a direction we cannot move in. It could, in principle, see the inside and outside of 3D objects at once, the same way you can see the whole interior of a 2D drawing from above. That's why higher dimensional beings in fiction seem magical. They wouldn't be breaking our physics. They would just be using geometry we can't directly navigate. And just to avoid a very common confusion, in relativity, people often call time the 4th dimension. That is a different idea. In this video, we are talking about a 4th spatial dimension, like the one used for tesseracts and hypercubes, not time as part of space-time. So what does 4D actually look like? Not a glowing hyperspace crystal, not a cube with extra lines, not something your eyes could ever capture all at once. It looks like impossible 3D slices. It looks like projections that almost make sense, but never fully click. It looks like geometry pressing against the limits of human intuition, and that almost is the closest we get. We may never directly see a true 4D object, but we can still reason about it, simulate it, and understand its logic. And honestly, that's one of the coolest things about math and physics. We can map realities our senses were never built to see. If this helped, like and subscribe for more fast space explainers, and comment. If a 4D object passed through your room, what do you think you'd see first?